In this video we will see kinetics of a rigid body. So here first method is D'Alembert method. In this method it is same as for the particle, but here in rigid body we have a rigid body which is having rotation with respect to point O and its center of gravity is G. So here there are various forces and moment is acting on this rigid body. This rigid body has a mass m. So if we draw this OG line which is having a distance of r, so O is the center of rotation and it is at r distance from the center of gravity of this solid body which is rigid. So here if we see omega and alpha are the angular velocity and angular acceleration of this center of gravity with respect to O. So here we do not have to look at the body now. Simply this body is the point G. We have to use G point to reference this body. Now we are having a normal acceleration of the center of gravity and tangential acceleration of center of gravity. Normal acceleration is r omega square. R is the distance from center of rotation to the G, and tangential acceleration is r alpha. Alpha is angular acceleration of G with respect to O. So r alpha. So tangential and normal acceleration we know. Now we have to apply this equation. These equations are similar as of the particle, but here we have in tangential normal direction separately. So in tangential direction mass into A tangential. So here m into r alpha. So summation of F tangential means summation of all the forces in tangential direction, tangential to this OG. So all the forces that are acting on this body in 80 direction we have to take it positive, in opposite direction we have to take it negative. So here summation of all the forces in tangential direction equal to mass times 80, which is equal to m r alpha. So here we have one equation. Second equation we will get summation of all the normal forces. This is the normal force normal acceleration direction will be equal to m into a normal, means a acceleration normal, so m into r omega square from this acceleration. So summation of all the forces which are acting on this body, we have to plot it here on the G, and we have to look at various forces, and if the forces are at angle we have to separate in two components, which is in normal and tangential direction, and those components we have to take in these equations. In tangential direction we have to take in tangential, in normal direction we have to take in second equation. So third equation is summation of moment at a G. So whatever the moment, whatever the forces and moment are acting, we have to take with respect to G point. So here let's say this force is passing through G, so there will be no moment by this force. This force is passing at some distance from the G, so perpendicular distance into the force will give moment at a G. So summation of all the moments calculated at G point will be equal to inertia at G point. So solid body inertia with respect to G point. So inertia, if it's a circular disc then it will be mr square by 2. It's a circular ring, then mr square. Like that all the inertia with respect to G point we have to calculate into angular acceleration alpha. This equation can also be written for any particular point. Summation of mp equal to ip into alpha. That will also be valid. Any arbitrary point we take, we have to take that particular point inertia and the same acceleration we will get from. So both this equation can be used. Let's say this p point is we have taken as O point. So here if we take all the forces moment, all the forces moment if we take with respect to O point, then we have to take inertia with respect to O point only. Similarly any point we can take on the body, outside the body, anywhere, we have to take these two value correspondingly. Inertia at p point, summation of moment at p point. So we'll get third equation. So p is any arbitrary point. Likewise all these three equations we have, we can calculate any of the variables. Specifically if we get alpha, then we place here and we find tangential, and we can find omega and all the variables from these three equations, and forces and center of gravity and geometry of the body will be given in the question. This is a bit lengthy problem. If it's a 2 mark problem, there will be some cancellation of forces, and if you draw a free body diagram of a solid body, and if you draw a diagram like this with respect to center of rotation, you will quickly solve this, and you have to frequently use this equation, both this equation, and afterward you will get alpha, and you can use in for tangential force. And once you find the tangential force, you can find normal force, because you will get this some r value or some whatever the missing value is there, you will get from that equation. So normal force also you can find. So in these three equations you can easily find all the variables. The second method is work energy method. So work energy method is same as work done on a body will be equal to change in kinetic energy of the body. So whatever the work done by the force and moment we have to take. So here work done by the force is summation of F dot ds, work done by the moment is summation of m dot theta. So here if there is no moment, we have to cancel this term. If there is no force, we have to cancel this term. Likewise this equation will be simplified, and you can use wherever applied in your format also. So you have to cancel all the terms, like theta is not there, then you can cancel this term. If there is no displacement, linear displacement, you can cancel this term. So likewise you have to use it. And change in kinetic energy on the other side will be linear kinetic energy change and rotational kinetic energy change. So here half m v square, v is a final velocity, u is a initial velocity, v square minus u square, and half ig, ig is the inertia with respect to g point, means center of gravity, into omega square is a final angular velocity minus omega naught square, which is initial angular velocity. So change in angular kinetic energy. So if both these terms we combine and we use single kinetic energy, which is a rotational kinetic energy, but there should be a pure rotation, and we know pure rotation there is no linear motion, so linear kinetic energy change will not occur. And here about I center there is pure rotation. So about I center, if we take half and inertia at I center of the body into omega I center square minus omega naught I center square. So this is how we can calculate a change in angular velocity with respect to I center. So at I center there is pure rotation, so we can use either this equation or this equation, whichever geometry is simple to find the inertia. So based on that we can use this equation, work energy method. The third method is impulse momentum method. So here it is same as this simple particle method, but in xy direction we have to separate. So let's consider there is a body which is represented by g point, and if you have initial velocity in x direction ux and in y direction uy, these are initial velocity, and angular velocity initial is omega naught. So initial condition is given, it is rotating with omega naught, ux is the linear velocity in x direction, uy is a linear velocity in y direction. So this is the initial condition. Final condition is vx, vy and omega. So these three velocity from initial condition changes to this velocity in final condition, and we are representing body by g. So here whatever the forces are acting in the x direction, we have to sum it and times into the time. So this time is the time about which this time is the time for which it is forces are acting on the particular body. So from here to here how much time is consumed, means the impact time for the forces. So this gets an impact in x direction, which will be change in momentum in x direction, m vx minus ux, final velocity and initial velocity. So impulse equal to change in momentum is a basic equation, and we have to separate it for x and y direction. So in y direction, summation of forces into the time of impact by the forces is equal to m vy minus ui. So here you have to separate in x direction, separate in y direction, and for moment angular velocity there is a separate equation. So angular velocity is changed by moment, so summation of moment at g by all the forces and by the moment, both this condition we have to calculate the moment at g. So at g into the time of impact of the moment and the forces, that will change the angular momentum of the body. So change in angular momentum is ig into omega minus omega naught. Omega is a final angular velocity, and omega naught is the initial angular velocity. So these three equations we can use and find all the variables which are given. Sometimes we have to use single equation and we get whatever we are finding. So this method seems lengthy, all these methods seems lengthy, but we do not have to calculate everything. These are the general form, we have to change it according to our requirement. And the final case we will discuss is rolling without slipping. This is a very common case asked in the examination, where there is a surface and this cylinder or a ball is rolling without any slipping. So slipping occurs when it's translating and there is a friction on the bottom side, but when in rolling there is a less friction and it is rolling like a wheel of a car. So here there will be eye center of the body, where the eye center has a zero velocity. So this particular point will have some velocity because it is moving, but there will be one particular point which is at the surface touching this rolling body. There will be eye center. So at eye center there is a pure rotation and there is no velocity. So velocity will be equal to 0. There is a force P acting, center of gravity is G, and radius of this rolling body is R. If we draw free body diagram, weight will be acting downward, P is a force which is applied, friction will be opposite to the motion at the eye center of contact point, and normal force will be acting at the contact point. So now if you consider this body at G point, and then there will be two acceleration, a normal acceleration and tangential acceleration, and there is angular acceleration alpha. We know normal acceleration is 0 because body is not gaining velocity in upward and downward direction. So normal acceleration will be 0. Body is only moving in tangential direction. Tangential means this particular line of rotation from eye center, it is rotating like this. G point is rotating. If you do not consider a roller, you consider simply the G point. Eye center has velocity 0 and G has some velocity. It is rotating like this. So tangential is in this direction. Now if we apply the equations or in D'Alembert method which we have discussed here, if we apply, then summation in x direction, which is tangential direction, will be m into tangential direction. So here tangential direction, we know it is m r alpha. So here m at is m r alpha, and summation of forces in tangential direction is p and f. So here simply we have to write p minus f, minus because tangential direction is a positive direction and p is in positive, f is in negative. So p minus f is equal to m r alpha. First equation we got like this. Second, we directly know that normal acceleration is 0, so summation of normal force is equal to m into an is 0. So here normal forces, we know w and n are there, so w minus n will be equal to 0, so w will be equal to n. Here summation of fn is w minus n will be equal to 0, so w will be equal to n, that we get from this equation. And in summation of moment at a G point equal to Ig into alpha. So summation of moment at G point, if we consider there are 4 forces and 3 of them are passing through G point, normal force, W and P. So moment is only occurred by friction force F. So friction force into R, and it is clockwise with respect to G point, and angular acceleration direction is also clockwise. So here both these are clockwise, so F is positive, F into R, that is moment. Ig is a inertia at a G point. So inertia for the cylinder, if we consider mr square by 2, and alpha is angular acceleration. From this equation we get this equation. If we cancel out R, this is the third equation we got, and whatever the values will given in the question, we have to place and find the missing variable. So this is how we calculate kinetics of a rigid body. And thank you for watching this video, and see you in the next video.